Hi, welcome to Bloom. The third chapter of A-level syllabus is on data representation. Today we are going to discuss the part 1 of the lesson, number systems. So let's see how data representation is done. When we are using digital devices, we encounter the problem how to represent data and give instruction to those digital devices. As you know, electronic devices only understand two states, on and off. These two states can be binary represented as 0 and 1. Then, how can we give instructions? Give different numbers, negative numbers, positive numbers, fractional numbers, characters, all these to digital devices. There are many number systems that are used. Here we will learn several number systems. The first number system we are going to learn is binary representation. As the name implies, binary has two values. In the normal numbering system we are using consists of 10 values. So it's called decimal representation. We use values from 0 to 9 to represent a number. Likewise, in binary representation there are two values, 0 and 1. In decimal representation it is 0 to 9, and binary representation it is two values, 0 and 1. So let's see how a number can be represented using these two values. When we are representing a number, each position of the number has different values. Rightmost position is called 0th position and this is the leftmost position. So this is 0th position, 1, 2, 3, 4 and 5. The binary represented number is multiplied by the position value to get the decimal value of the binary represented number. For example, this position has the value 2 to the power 0. We use the representation value, that is 2, as the base and the position as the exponent. This is the first position, so 2 to the power 1. The exponent is the position and the representation base is considered as the base. So this is the second position, so 2 to the power 2. This is third position, so it is 2 to the power 3. So let's see how we can represent a number using this binary representation. In this example, we saw these positions have different values, and when we are deriving the decimal value of the binary represented number, we have to multiply by this digit value. For example, this is the 2 to the power 0 position. The position value is multiplied by 1. So it is 1. Position value here is 2, but it is multiplied with this 0, then returns 0. Here it is 2 to the power 2, position value is 4, it is multiplied by 1, so we get 4. Here position value is 8 and it is multiplied with 0. Here the position value is 16 and it is multiplied with 0. Then here the position value is 32, that is 2 to the power 5. This is 0, 1, 2, 3, 4 and 5. So the position value is 2 to the power 5, that means 32. It is multiplied with 1. So here the value is 32. Then after that we have to add those position values. 1, 0, 4, 0, 0, 32. Then it returns 37. That is from the decimal representation of this binary number. Let's see another example. Here we have the binary numbers 1, 0, 1, 1, 0. We have to find the position values. This is 1, 2, 4, 8, 16. Then we have to multiply with the respective binary digit. When we have zeros, it returns 0. And when other values are multiplied with this digit, then here it returns 2, this 4 and 16. So we get the decimal representation of this binary number is 22. Now let's learn octal representation. In binary representation we have two values. In octal representation we have 8 values, that is 0 to 7. 1, 2, 0, 1, 2, 3, 4, 5, 6 and 7. And like binary representation, each position has different position values. This is 0th position, 1, 2, 3 likewise, and it is a number of types into the base. Each position has different values. 0th position, first position, second, third likewise. In binary representation we use 2 as the base. In octal representation we use 8 as the base. So e to the power the position, e to the power 0, this one position value is 1, 8 into the power of 1, that is 8. Here 8 to the power 2, 64, and here 8 to the power 3. Let's look at an example. We have 5, 3, 1. In octal representation we can't have any numbers above 7, that is 8 or 9 we can't have in an octal representation. The position value is e to the power 0, that is 1. Here position value is e to the power 1, that is 8, and here the position value is e to the power 2, that is 64. Like in binary representation, what we did was we multiplied the value here with the position value. In the same manner, in octal representation we multiply the position value with the value, the digit here. So here we multiply with 1, here we multiply with 3, here we multiply with 5. So here 1 into 1, 1, here 8 into 3, 24, 4 into 5, and we get the total 345. Let's take another example. Here we have the octal number 10167. Again we have to find the position values. Here 1, here 8, here 64, and here we don't need, as we have to when we multiply by 0, it's 0. Here 4096. Then after that we have to multiply with the value. 1 multiply with 7, 8 multiply with 6, here 64 multiply with 1, and here 8 to the power 4 multiply with 1. Here we can get the decimal representation. We learned both binary and octal representation. Now let's learn what is hexadecimal representation. In binary representation we had 2 numbers. In octal representation we had 8 numbers, that is 0 to 7. Then in decimal representation, the numbering system we normally use, we have 10 numbers, 0 to 9. In hexadecimal means 16. So we need 16 different kind of digits. So in decimal representation we get 10, that is 0 to 9. So how to represent the remaining 6 values? For that we use Roman characters A, B, C, D, E, F, the values to represent digits. So again, like in binary and octal representation, each position has different position values which should be multiplied with the digit represented here. For example, let's say we have a number 1A9. So this is the 0th position, the first position, and the second position. So in hexadecimal the base is 16, and we have the position number as the exponent. So here the position value is 1, the position value here is 16, and here the position value is 16 to the power 2, that is 256. We multiply 1 with the value here 9, and then here the position value is 16, we multiply with A. The A represent 10. Here we have 1, 2, 3, 4, 5, 6, 7 up to 9. Then A means 10, B means 11, C means 12, D 13, E 14, F 15. Instead of A, if we had F, we put 15 here. Then here the position value is 16 into the power 2. It is multiplied with this value 1. So we get the decimal value of this hexadecimal value, that is 425. Thank you for watching the video. Please join to watch the next part of the lesson, negative binary numbers.